The topic is improving quality and saving some hours, 2,500. When we made it, it was not about saving hours, it was about improving our quality of the software. Perhaps short about Schneider Electric, what is it? I don't know if you know the company, so we are a big player in energy management. Comes everything which relates to energy from push button, where today even push buttons could be wireless, and the energy just by pressing down accelerates the transmission up to energy plant control, automation in factories for car manufacturing, car painting, chemical processes. So all areas where you can think about energy and automation, we are at home. So we have about 110,000 employees worldwide in a lot of countries, and we spend a significant amount of the sales also on R&D. I guess that's enough on this topic. For me, just that you know a little bit more about me, I'm close to 50, already 48. I have a son of 21 and I'm married, so you know now where my money goes to. And I started my professional life as developer, so I pretty well know what is enemy and friend of developers, and ended as project manager in the R&D part. You heard already about certified Scrum Master, and I'm Agile consultant. And today I be in Schneider Electric Software Quality Director. Wow. In general, about this picture, we don't have to speak too much. I guess you all know about having a bug at customer costs this, and having a bug in implementation, it's a cost like that. So it's exponential, and the idea is to bring it from the back to the front. We heard about this 2 times, I guess, and so we don't have to look too much into this picture. And what I like to discuss, or not to discuss, to talk a little bit about the quality puzzle. I call it quality puzzle because a lot of times people, when they speak about quality, they think quality, we have to improve the process. We have to run for CMMI level 2, 3, whatever, or CMMI. But what is quality really? At the end, it's everything together, and we miss a lot of times that in the core there are the people, and people means they make it or they don't make it, and they are supported by a lot of things, by tools, reviews, and so on. And for sure a process, whatever this process is about, if it's Scrum or waterfall process, I don't care in the moment. And what we do in the moment at Schneider, we are focusing on tools, control, rules, and people. For the rest, we spend years, 10 years, 20 years to improve our process inside. But for the rest, we have not spent too much time. What does not mean that we have not used PC Lint. Good. Now, about our system, what I'm talking today about, it's just a piece of what Schneider is doing. Where we used Coverity and are still using was a new IDE. I call it IDE like Visual C++ to program our controllers to automate the system. Such a system has several languages. You can have structured text, which is like Pascal, so a textual language, or you can program in graphics, and you just form your algorithm, and you compile and you download to your controller. And the system, these are the figures from 2008, was about 2.5 million lines of C++ code, a lot of components. A component is a DLL at the end of the hard disk. The technology, okay, it's today no longer the most appropriate for desktop programming, but it was C++, MFC, and so on. And while you know this picture, that's this Coverity. I don't have to explain that. Why did we start to use Coverity? It started in 2006 with serious issues. At this time, I was project manager of this, we call it Code Monster. It was the first time that we had a distributed programming environment. Distributed means we had colleagues in France, in North America, in Germany, and no, India came later. And this was something we never faced before. And bringing the stuff together, even having written good documents or whatever we call the good documents, we had real problems to make it stable and to come to the stage gate to deliver it. So we started a huge quality improvement program. And when you look back and remember the puzzle, we worked on all the pieces of the puzzle, which I don't touch now, so on architecture, documents, and so on. And one part was static code analysis and code coverage. So what did we do? We analyzed the market, all the competitors, the main players on the market on static code analysis, we evaluated with our developers. So clearly, vendors always say it's the best tool. That's true, that's normal. And so we really used 10 key developers, really senior developers, to check 3 major players on the market on static code analysis. And what should they do? They were asked to look to their code after a short training to use the tool about usability, quality of results, and also false positive rate to really see how many time do we spend hunting bugs which are no bugs. Of course, that's also time. And key is the red piece of the puzzle. It's to convince the developers. It is not to ask them to use the tool, it's to convince them. And that their acceptance at the developer's desk is elementary. And so, how did we achieve that? On the one hand, they were part of the story to evaluate all the tools. They were asked to, with a set of questions, to answer how good, how bad, what do you think, what is the GUI, what is the result, what do you think about false positives with the tool. And at the last question, what do you think, what of the 3 tools we should purchase? And the clear answer on this was in 2006, we should go for Coverity. And we had a server installation. At this time, there was no integrated version possible. And we had a runtime, means analyze time, of about 2 weeks in the beginning. That means 2 weeks of run of Coverity on a server to present the result. And we came down to 1 week afterwards. And once we had a server issue on Friday. On Monday, the developers were calling the administrator, hey, Bernd, what's going on? We need the results. That was the point in time where we said they have accepted it. Before with PC-Lint, we had tons of data somewhere on the server. Nobody would ever check that no new data was created. And hey, good. We started with Coverity 3.6 up to 4.3 on this project, which, as I stated, it was not integrated to Visual C++. Or it was even 21 days, down to 7 days. And the product was pretty complex. And our build was not perfect, so we had to run several loops to make it. That was not the issue of Coverity itself. And what we did is, because, well, one thing is, they evaluated the tool, but then after having started to work with the tool, we wanted to know how good is the tool in reality. How many issues are really found and reported by the developers, reported by the tools and rated by the developers as critical, urgent, and high. Critical, urgent, high would mean it could lead to a serious issue at customer. So, because the tool for sure found thousands, but what are the real things which would crash the system, which could cause a malfunction or so on? And that was a feedback loop, which the developer could rate inside the tool something and could give a statement. It's something like a showstopper or something like that. And so we use this feedback to check the quality of the tool. And after 2 years, I guess this is from 2008, we found 167 critical and high-rated issues, which, as I stated, could have been or become showstoppers or serious issues. And even in the past, we knew, or we said, to fix the bug, it will cost us 2 days. in average. It's clear some bugs are fixed in 10 minutes, others in 2 weeks, from the detection to the fix to the generation and so on. And so it was pretty easy to calculate the ROI, because my managers were asking me, what is the ROI of this tool? Is there an ROI? And so we were looking for this with this pretty easy formula. So we used 167 of bugs, or I say issues. I was not allowed to write bugs because our tool only has issues, no bugs. And by 2 days means it's 334, a little bit like 2,500. If you make it's a little bit less or more. And I even do not look about, is it exactly this? Because if it's 3 days, 5 days, 1 day, I don't care. We had reached ROI after 9 months in 2008, or 2000, yeah, it was 2008, and it's still used today. So that is where the magic number of 2,500 comes from. And with this ROI calculation, it was pretty easy to show the management that it's really valuable to use this tool. And it's really the information. The origin of the information is the developer's desk and not somewhere a PowerPoint or me who said, wow, it's a good tool, we should use it. And it's always checkable. For sure, it can be more or less, so that's why I don't care, 9 months, 12 months, but, and information comes from the developers. And at the end, the outlook is clearly, what does a company ask for? How can we save more? It's clear we just used it in one development center on one product, and it's what can we do more is about to leverage this to full Schneider Electric software departments, and this project is called Qualimetry. We are doing, which the core is static code analysis. You will see later, this is one pillar, and we also do ISO 9126 measurement, which means quality measurement from the eagle view to the software, where you check maintainability, testability, and so on and so forth. We've seen this term on his slide before, but this is not the topic today. And looking to how many developers Schneider has worldwide, we are about more than 2,500 in 60 R&D centers, a lot today in India and Bangalore. And this program has started beginning of 2011. I'm leading this, and today it's a position where I analyze together with some colleagues all entities, where they are, what they have or more don't have, and what they need to make a rollout next year and the year after. 4 elements which are in this, and you will see. This Qualimetry project has 3 pillars. One thing is we want to prevent bugs introduced to the code, mainly by rules checker, automated rules checker. This is a lot of times questioned by people who are doing embedded firmware. MISRA, JSF rules checking is always questioned there. The core element is to detect the bugs with static code analysis, and the rest, what I told you, is the measure and monitor quality for software code quality indicators following this standard.